Why Jupiter is the scariest planet. You've been lied to your entire life. They told you Jupiter was Earth's guardian, a shield, a massive protector standing between us and cosmic chaos. A benevolent giant sacrificing itself by pulling asteroids away from the inner solar system. It's beautiful and comforting and completely wrong. Jupiter isn't protecting us. Jupiter is threatening us. Right now, it's the most dangerous thing in the solar system besides the sun, and it's been getting worse. The radiation it's emitting is lethal. The gravity it's wielding is destabilizing. The magnetic field it's generating is warping space itself. Worse of all, Jupiter shouldn't even exist as it is. Because Jupiter isn't a planet, it's a failed star. A cosmic near-miss that came close to igniting as a second sun. Scientists still can't explain why it didn't become a star. If our understanding of Jupiter's formation is correct, everything we believe about planetary systems might be backwards. We might be living on borrowed time. And Jupiter is the clock. Let me show you what we got wrong. For centuries, we looked at Jupiter and saw majesty. A swirling gas giant, beautiful and distant, the largest planet in our solar system. In the 1600s, Galileo pointed a telescope at it and saw 4 moons. They orbited like a miniature solar system, and it felt designed and protective. When celestial mechanics evolved, we mapped gravitational influences and realized Jupiter pulls some asteroids. The famous narrative took hold. Jupiter is our shield. It's comforting, and it's a lie by omission, because here's what they don't tell you. Jupiter is also pulling asteroids toward us. The gravitational dynamics of Jupiter are chaotic and unstable. A single asteroid in the wrong orbit can be perturbed by Jupiter and sent spinning into the inner solar system. 65 million years ago, an asteroid 10 kilometers wide hit the Yucatan and wiped out the dinosaurs. We don't know if Jupiter nudged that asteroid toward us or away. We don't know how many extinction-level impacts Jupiter has caused. We know Jupiter deflects some asteroids, but we don't know the net balance. Jupiter might be killing us more often than it's saving us. But that's just asteroids, and small stakes compared to what's happening on Jupiter itself. Let me take you inside the radiation zone. Jupiter emits radiation, not just reflected sunlight. Thermal radiation is leaking from its core, heat that shouldn't be there. A planet this far from the sun shouldn't give off that much energy. In fact, Jupiter radiates nearly twice as much heat as it receives from the sun. It's like Jupiter is internally powered, as if something inside it is still burning. Scientists call it the heat excess, and we don't fully understand it. The leading theory is that Jupiter is still contracting, releasing gravitational energy as heat. Jupiter is gradually contracting, shrinking, and becoming denser. Over billions of years, that compression might trigger deuterium fusion, turning Jupiter into a brown dwarf, a failed star, a small second sun orbiting our own. That would put 2 stars in the system and likely wreak havoc on the solar system, though that outcome is speculative. What isn't speculative is what's happening now. Jupiter's magnetosphere traps radiation. Charged particles from the solar wind get caught in its magnetic field, spiral along field lines, and accelerate to near-light speeds. The resulting plasma is so energetic and radiation-rich that it would be instantly lethal across millions of kilometers. The strongest radiation environment in the solar system is around Jupiter, not the sun. Jupiter's radiation belts are about 10,000 times stronger than Earth's Van Allen belts. An unshielded spacecraft passing through would deliver a fatal dose in seconds, destroying cells and DNA and causing catastrophic neural damage. Worryingly, that radiation is growing. Voyager mapped the belts in the 1970s. Juno observed the same region in 2016 and found stronger radiation. We don't know the cause, whether it's temporary or whether it's spreading toward Earth, and we can't stop it. Earth's magnetic field shields us from solar radiation, but it has been weakening over the past 2,000 years. If the decline continues, within a few hundred years, we could lose that protection, risking atmospheric loss and sterilization of the surface. It's unclear whether Jupiter's changing radiation could influence Earth's magnetosphere. Physics suggests the fields are too distant to interact directly, but gaps in our understanding leave room for uncertainty. Jupiter's gravity adds another danger. It contains more mass than all other planets combined and exerts enormous force. At the cloud's surface, you'd feel about 2.5 G, enough to crush a human under their own weight. Deeper down, pressure rises dramatically, hydrogen turns to liquid and then into exotic metallic hydrogen under extreme conditions. A state of matter we can barely create in laboratories, where electrons are ripped from atoms and flow like a liquid metal. And Jupiter's gravity is still increasing, still compressing, layer after layer. The pressure and temperature rising geometrically, until, at the core, scientists estimate there's an Earth-sized rocky core surrounded by a mantle of metallic hydrogen, surrounded by liquid hydrogen, surrounded by gaseous hydrogen, wrapped in storms and radiation. And Earth sits at the center of Jupiter, crushed, invisible, erased by pressure. Now here's where gravity becomes dangerous for us. Jupiter's gravity reach extends across the solar system. It's not just holding Jupiter's moons, it's influencing Saturn. It's nudging Uranus. It's creating resonances patterns of orbital harmony where objects get trapped in gravitational locks. An asteroid in the right orbit at the right distance from Jupiter can lock into a pattern where every time it orbits the Sun, Jupiter pulls it at the same point in its orbit. This happens thousands of times, millions of times. And over time, the gravitational impulses add up. The asteroid gets knocked out of its original orbit. It spirals inward toward the inner solar system, toward Earth. We think the late heavy bombardment, when the solar system was flooded with asteroids 4 billion years ago, was partly caused by Jupiter's gravity destabilizing the ancient asteroid belt. Hundreds of thousands of rocks hit Earth, Moon, and Mars. Mars lost its atmosphere. Earth was bombarded with so much energy that the oceans boiled. Life barely survived, and Jupiter did that, not intentionally, not maliciously, just by existing, just by being massive and gravitationally present. Jupiter's gravity is like a storm system in the solar system. It moves things around unpredictably. Sometimes that's deflection, sometimes that's redirection, sometimes that's acceleration toward Earth. We can't predict which. And this is where the narrative breaks down completely, because Jupiter's orbit isn't stable, not long-term. Orbital mechanics suggest that Jupiter, Saturn, Uranus, and Neptune have migrated. Billions of years ago, Jupiter formed closer to the Sun. Then, through gravitational interactions with the protoplanetary disk, the cloud of gas and dust that formed the solar system, Jupiter migrated outward. It may have moved in and out several times, creating chaos, destabilizing planetary orbits, possibly scattering planets entirely. Earth might have almost been thrown into the Sun, or ejected into interstellar space. We only exist because Jupiter's migration stopped at a certain point. We're in a specific solar system configuration because of Jupiter's past movements. And Jupiter's movements weren't stable. They were chaotic. A tiny difference in initial conditions and the entire solar system would be different. We might not exist at all. But let's talk about what's actually terrifying. The thing that keeps planetary scientists awake at night. Jupiter might not stay in its current orbit. Orbital instabilities take billions of years to fully develop, but they're inevitable. Jupiter's gravity is still tugging on Saturn. Saturn is still tugging on Uranus. Uranus is still tugging on Neptune. And all of them are slowly, incrementally pulling each other into slightly different orbits. Eventually, maybe in the next few billion years, maybe not for trillions, one of these perturbations might grow too large. Jupiter could migrate inward. If Jupiter moved closer to the Sun, its gravity would intensify. Its pull on asteroids would increase. The radiation belt would expand, and the solar system would transform. Planets might be ejected. Orbits would become chaotic. Earth could be knocked into a different orbit, moving toward the Sun or away from it. If Earth moved closer to the Sun, the oceans would boil. If Earth moved farther away, it would freeze. Either way, life ends. And Jupiter is not doing this maliciously, it's just following the laws of gravity. Its orbital mechanics inevitably lead to instability over long enough time scales. Every multi-body gravitational system eventually becomes chaotic. Every planet eventually destabilizes every other planet. Jupiter is a slow-moving catastrophe. We just discovered that Jupiter has been emitting strange signals. In 2020, radio telescopes detected unusual bursts of radiation coming from Jupiter. Not the expected synchrotron radiation from its magnetosphere, different structured, organized, like signals. The bursts follow a pattern. They peak in intensity, then fade, then spike again. And they are not coming from any identified source on Jupiter. Scientists have theories, atmospheric discharge interactions between the magnetosphere and the moon's solar wind instabilities. But the truth is, we do not know. We built a spacecraft, Juno, specifically to study Jupiter, and Juno is finding anomalies we cannot explain. Unexpected radiation, unexpected magnetic field strengths, unexpected atmospheric dynamics. Jupiter is stranger than we thought. And if Jupiter is stranger, if it is more volatile, if we do not fully understand it, then we do not fully understand our own solar system. And if we do not understand our solar system, then we cannot predict long-term stability. We cannot say with certainty that Earth will remain in a habitable orbit for the next billion years. We can only say that Jupiter is out there massive and unpredictable, and everything in this solar system lives in its shadow. But let me take you deeper into the horror, because Jupiter's moons are terrifying in their own right. Europa, Ganymede, Io, Callisto, 4 bodies orbiting Jupiter, each one being pulled and stretched and heated by Jupiter's gravity. Io especially is in agony. It is tidally heated to the point of constant volcanism. Hundreds of active volcanoes covering the surface, lava lakes, sulfur geysers, a world in constant convulsion because it is trapped in Jupiter's gravity, being squeezed and released with every orbit. Io is slowly spiraling inward. In millions of years, it will hit Jupiter's atmosphere. It will be vaporized. And before it dies, the friction will heat it further. It will erupt. It will tear itself apart from the inside out. And we are watching it happen in slow motion. Europa and Ganymede moons that scientists believe might harbor life in their subsurface oceans are also being heated and deformed by Jupiter's gravity. The tidal forces are so intense that it keeps their cores warm. It keeps water liquid beneath the ice. Without Jupiter's gravity, those oceans would freeze. The moons would become cold, dead, sterile. Jupiter is simultaneously creating the conditions for life and the conditions for its destruction. Because those tidal forces are also slowly tearing the moons apart. Europa is developing cracks that leak water into space, water that escapes, moons that are being eroded by the very forces that made them potentially habitable. Eventually, the moons will break, they'll scatter, and everything living in those oceans, if anything lives there, will die. Jupiter is a parent slowly devouring its children. And here's the final devastating revelation. We don't know how many bodies Jupiter has captured. We know the 4 large Galilean moons, Europa, Ganymede, Io, and Callisto. But Jupiter has 80 moons total, 80. Most of them small. Most of them irregular asteroids trapped by Jupiter's gravity and slowly spiraling inward. And we don't know the full list. New moons are discovered every year. Some might be dark matter trapped in gravitation locks. Some might be ancient objects from the early solar system. Some might be recent captures, asteroids that wandered too close and got trapped. Jupiter is a trap, a gravity well slowly accumulating cosmic debris. And if we ever detected an object on a collision course with Earth, if we ever discovered an asteroid we needed to deflect, we'd have to understand Jupiter's gravity perfectly, because any deflection we make might be undone by Jupiter. Any trajectory we calculate might be disrupted by Jupiter's pull. We might spend billions of dollars deflecting an asteroid away from Earth, only to have Jupiter's gravity curve it back. We'd be fighting an invisible enemy we don't fully understand. But here's the thought that should crush you with existential weight. Jupiter wasn't supposed to exist like this. According to our models of planetary formation, Jupiter should be either a star or a rogue planet wandering interstellar space. It's too massive to be a normal planet. It has too much hydrogen. It should have continued accumulating gas until it became a brown dwarf. It should have ignited. It should have become a second sun. But it didn't. Something stopped it. Something prevented Jupiter from accumulating just a little bit more gas. Something prevented it from reaching the critical mass where deuterium fusion ignites. We don't know what. We call it the migration halt. Jupiter formed, started accreting gas. Then, for reasons we don't understand, the accretion stopped, and Jupiter became frozen, trapped in an intermediate state. A failed star, a protostar that never finished, which means Jupiter is unstable by definition. It's an intermediate object, and intermediate objects are inherently unstable. They want to complete the transformation, to become either a planet or a star. And if Jupiter ever tips, if the balance ever shifts, if the core temperature ever rises above the deuterium burning threshold, Jupiter ignites. We'd have a second star in the solar system overnight. The radiation would sterilize Earth instantly. The heat would vaporize the oceans. Life would end in nanoseconds, and there's nothing we could do. We couldn't move planets. We couldn't shield Earth. We'd just die quietly in the night as our solar system transformed into a binary star system. Is this likely? No. The core of Jupiter is hot, but not that hot, not yet. It would take millions of years for gravitational compression to raise the temperature that much. But is it possible? Yes.